This is electron configuration in 2 minutes.
From GCSEs, we know that electrons exist in shells, otherwise known as energy levels. These are made out of subshells, which are made out of orbitals, which contain 2 electrons with opposite spin within them. The first subshell is an s subshell, which contains 1 orbital, meaning it can hold a total of 2 electrons within it. The second subshell is a p subshell, which contains 3 orbitals, which means it can hold 3 lots of 2 electrons, meaning it can hold 6 electrons in total. For d subshells, it's 5 orbitals, meaning 10 electrons are in it. And for f subshells, it's 7 orbitals and 14 electrons. In terms of shape, the s subshell has a spherical shape and the p subshell has a dumbbell shape. Now, the first energy level in an atom only has a 1s subshell, meaning it can only hold 2 electrons. The second energy level also has a p subshell, meaning it can hold 8 electrons. In the third energy level, you have the 3s, the 3p, and the 3d, so it can hold 18 electrons. Whereas in the fourth energy level, we have a 4s, 4p, 4d, and 4f subshell, meaning a total of 32 electrons can be held. Now, when writing electron configurations, this is the order that the subshell should be in. The thing to look out for here is the 4s and the 3d, because you would expect 4s to come after 3d, but in fact it comes before as it has a lower energy level. When writing electron configurations, the number represents the energy level, the letter represents the subshell, and the superscript number represents the number of electrons in that subshell. For example, if we wanted to write down the electron configuration for oxygen, we'd first look at its atomic number, which is 8, which tells us it has 8 electrons in it. 2 of those electrons will go to its 1s subshell, another 2 to its 2s subshell, and that leaves 4 left, which get filled up in the 2p subshell. Makes the electron configuration 1s2, 2s2, 2p4. You can also use a box diagram to represent the electron configuration, where each box represents an orbital. In the 1s, we put arrows, one up, one down, to represent electrons with opposite spin. Same with 2s. For the 2p subshell, you need to remember to fill in the electrons individually first before pairing them up, because they're more stable this way.
This was obviously a very quick summary. For a longer, more detailed explanation of the topic, check out the link to the full lesson and subscribe to my channel.